everyone, how are you all doing? Well, in today's video, let's discuss the part 8 of matrices. The topics we're going to cover are minors of matrices, cofactors of matrices, adjoint of a 2 by 2 matrix, adjoint of a 3 by 3 matrix, and division of matrices. Let's begin. Now, before I discuss the minors of a matrix, let me introduce you to the new topic, that is adjoint of a matrix. In order to find out the adjoint of a matrix, let me tell you we'll be able to clear this topic in our further slides. Alright, this is basically resembled as ADJ into A. Here A is the matrix name and ADJ is not adjacent, it is adjoint. Alright, so ADJ, A is the adjoint of matrix A. Alright, in order to find out the adjoint of a matrix, here we need two important things. They are minors and cofactors. These are the two important things that we require in order to find out the adjoint of any matrix. And that is why we are dealing with minors of matrix first. Now, let's say I have a matrix A which is equal to A, B, C, D. Now, if I say I need to find out the minors of this matrix. Before I even find out the minors of this matrix, let me introduce you to one concept. Alright. Now we are calling this as the first element, second element, third element, fourth element from our previous videos. But let me make you more clear of how we call these elements. Alright. They are generally called as M11, M12, M21, M22. This matrix can be in this manner. Why are we calling in this manner? Why not I call it as M01, M02, M03 or M12, anything of my wish. Why can't I call them like that? Well, here the 1 over here resemble row and the column in which it belongs to. Fine. That means M11, that is here A. A belongs to the first row, first column. That is what it says. Here M12, that is B. It belongs to the first row, second column. Fine. Then when I talk about M21, it belongs to the second row, first column. M22, second row, second column. In this way, we generally call matrices. We call it as M11, M12, M21, M22 and so on. Alright. Firstly, here M11 will be the minor of 1, 1. It is not matrix M. Previously, we have dealt with M11 where it means M is equal to 1 matrix and we have done that. But here M resembles minors. Okay, generally you have matrices in A is equal to 0, 1, 0, 1 or let's say B is equal to some matrix. But we do not have some M is equal to 1 matrix or something like that. We generally use A and B. Alright, here M is very important. Okay, M over here is minor. It's not matrix. Alright, so M11. Firstly, let's find out minor of 1, 1. That is minor of A. This is nothing but minor of A. What is minor of A? That is what we are going to find out. How do we do that? Well, let me write A again. A, B, C, D. Alright. Matrix A is equal to A, B, C, D. Now look at what I'm going to do. Okay. Here, whichever the row and column A belongs to, I'm simply going to cut them. What am I left with? I am left with D. That will be the minor of A. That is M11 will be D. Fine. Now what if I say I need to find out minor of M12? What is minor of M12? Let me tell you. Cut down all the rows and columns where B belongs to. What do you get over here? C. So the minor of B. Why B? Because in M12 place we have B. So minor of B will be C. Alright. In this way you're going to find out all the minors. Now let's find out the M21. What is M21 gonna be equal to? Here I'm going to cut down wherever the row and column C belongs to because I'm going to find out the minor of C. What is the minor of C that I got? Here I got M21 as B. Remember that here M is not matrix, it is minor. Alright. Then I have my last element. I'm not going to call last element any longer. I'm going to call M22. What is the minor of 22? That is D. What is the minor of D? Let me cut down the rows and columns it belongs to. What am I left with? A. So in this manner, we are going to find out the minors of matrices. Now the next most important thing that we need to know in order to find out an adjoint of a matrix is the cofactors. Now for the cofactors of matrices, let us bring down the information of minors because that is very helpful over here. So in the previous slide, we have calculated the minor values of every element. Here they are. Now in order to find cofactors, minors play an important role. So here we bring on the minors table. Alright. Now how do we find out the cofactors? Let me tell you. Resemble them as C11, C12, C21, C22. In this way you are gonna resemble them. Alright. Now using minors information, you're going to find out cofactors of a matrix. Well, firstly tell me here what is the number that we have? We have 11. Alright. Whatever the digits that are there, add them once. What do you get? You get 2, which is an even number. Remember that cofactors have a good relationship with even numbers. So they do not harm the even numbers. What do I say right now? Here when the sum of rows and columns is even, then whatever is the minor, so will be the cofactor. That means minors and cofactors will be only friends when the rows and columns are, the sum of rows and columns will be equal to an even number. That is when they will be same. Now moving forward, let's take 12. 1 plus 2 is 3, which is an odd number. So definitely they are enemies. So if minor is C, then cofactor will be minus C. It will be completely opposite. Alright, you will be having opposite signs. Now, take minor 2, 1. Here 2 plus 1, that is 3. Now tell me, 3 is an odd number. So there will be enmity. And then there will be change in sign. Here B will be changed into minus B. So cofactor to 1 will be minus B. Now tell me the last one. It is 2, 2. That is 2 plus 2 equals 4. Here we have an even number. So certainly they have a good relationship. So here the signs are not going to change. Well, the number is going to be the same. That is A. In this manner, you're going to find out the cofactor of any matrix. Remember that signs only differ when the sum of rows and columns is odd. Okay. Whereas when it is even, it will be the same. When it is even, cofactor will be equal to minor. Fine. Moving forward, let's find out the adjoint of a 2 by 2 matrix. taking the previous example itself. Now we had A is equal to A, B, C, D, isn't it? Now we got minors and we got cofactors. In order to find an adjoint of any matrix, remember that minors are none of the things that we're going to use over here. Minors are only helpful for cofactors. Okay. Now cofactors are helpful for adjoints. That is, we have used minors for our cofactors. Now adjoint will use cofactors for its calculation. Alright. Now we do not have anything to do with the minors. Minors are none of our concern. Let's take on the cofactors data. Now what is the formula for adjoint? Well, adjoint of A over here will be equal to Cij transpose. Now what do I mean by Ij, C and T over the top? Well, C is the cofactor. By now you must be aware of it. I is the number of rows. Number of columns will be J. Right, here we have columns. And T is transpose, which we are already aware of in the previous videos. Right, transpose. Fine. Now what is adjoint of A? Cig whole T. That is transpose of cofactors. What do I mean by that? Here do not over stress on Ij. It is none of our concern. Here I'll tell you what it is. Look at all the C, that is all the cofactors. Now make out a matrix of cofactors. What do you get? C11 will be the first one. C12 will be over here. C21 will be over here. And C22 will be over here. Now the transpose of this matrix is nothing but adjoint of A. As simple as that. Alright. Now what will be the transpose of this? The transpose of this is going to be D minus C minus BA. As simple as that. This will be the adjoint of A. Now for finding out adjoint of A, we have done a lot of things. We have first found out the minors. Now with the help of minors, we have found out the cofactors. Now with the help of cofactors, we have found out the adjoint of A. How do we find out minors? Now let us revise everything. Minors were found out by, if suppose I need to find out the minor of A, I cut down all the rows and columns it belongs to, and the minor of A is D. The rest out element will be the minor of A. In this way we found out minors. Now what about cofactors? If the sum of rows and columns is even, then there will be same signs. That means the numbers, the elements will be same for minors and cofactors. But if they are different, that means if the sum of the rows and columns is odd, then they'll have enmity and the signs will differ. If it is D, it will become minus D and so on. In that way we found out cofactors. Now with the help of cofactors, how did we find out adjoint? Well, it is the transpose of the matrix of cofactors. In that way we found out the adjoint of the matrix of the order 2 by 2. Well, that was hefty to remember. Now let's find out adjoint of a 3 by 3 matrix. Now here I'm going to take on a matrix. A is equal to 1, 2, 3, 4, 5, 6, 0, 1, 0. Fine, this is my matrix A, not being very complex. Now if I need to find out the adjoint of this matrix, what do I do? First of all, find out the minors. M11 will be equal to what? Let me tell you, the same concept is applied. Cut down all the rows and columns 1 belong to, because 1 is M11. And here you will be left out with a 2 by 2 matrix where you're going to multiply the diagonal elements first, minus 6 into 1. That is the non-diagonal elements. So 0 minus 6 is minus 6. So here M11 will be minus 6. Fine. Now let's find out M12. What will that be? Let me tell you over here. M12 will be equal to, let's cut down all the rows and columns M12 belong to. Now we'll be left out with a 2 by 2 matrix, that is 4, 6, 0, 0. Now multiply the diagonal elements first and then the non-diagonal elements. You'll have 0, isn't it? Here this is minus. Alright. So 4 into 0 minus 6 into 0, that is 0. So here M12 will be 0. Now what about M13? Let me cut down the rows and columns it belongs to, and we'll be left out with a 2 by 2 matrix over here. 4 into 1 minus 5 into 0, that is 4 minus 0, that is 4. So here you're going to have 4. In this manner, you're going to find out all the elements, right? The minors of all the elements. Now let us find out M21, then M22, then M23. We have a lot to find out. Let us do that. Now here, I'm cutting down all the rows and columns it belongs to. Fine. Here, I'm talking about 4. Okay, because it is M21. Here, we are being left out with 2, 3, 1, 0. That is 2 into 0 minus 1 into 3. 0 minus 3, that is minus 3. So, the minor of 2, 1 is minus 3. Then, let's find out for 5. Right. Again, we are left out with a 2 by 2 matrix. 1, 3, 0, 0. Now again, 1 into 0 minus 3 into 0, it will be 0, right? So here, M22 will be 0. Then M23. Again, we are left out with a 2 by 2 matrix. 1, 2, 0, 1. 1 into 1 minus 2 into 0, that is 1 minus 0, 1. So here, M23 will be 1. Now let's find out M31. Here it's going to be in this manner. Again, we have a 2 by 2 matrix, right? 2, 3, 5, 6 will be our 2 by 2 matrix. That is going to be 2 into 6 minus 5 into 3. That is 12 minus 15 minus 3. So here you're going to have minus 3. Then we have the second element in the third row, that is M32. So here it is 1. Fine. Now this is going to be cut in this manner. Then we have 1 into 6 minus 4 into 3. That is 6 minus 12 minus 6. So here you're going to have minus 6. Find the next element is 0. Here we're going to cut down again. So 5 into 1 minus 4 into 2. That is 5 minus 8. That is minus 3. So here you're going to have minus 3. Alright. Now if I say find out M32 in this matrix, how do you find out M32? Come on, yaar. It's going to be the third row. Fine. 1, 2, 3. Third row, second column. So your M32 will be over here. Make sure you do it in a proper manner. Alright. So in this way, we found out all the minors. Now that is not the end. You gotta find out adjoint of this matrix. So with the minors, now let's find out the cofactors. Now M11 and C11 will be equal to minus 6. Why? That is because 1 plus 1 over here is 2. It's even. When it is even, it is the same number. When it's odd, the signs get changed. Alright, a simple fundamental that you have to remember. Alright. Now if you look over C12 and look at the number that is over here, 0. Even if you're going to change sign or not, 0 will be 0 always, isn't it? 0 is neither negative nor positive. Then M13 will be equal to C13 because 1 plus 3 is 4 and 4 is an even number. So the number over here will be equal to number over here. Alright. Now let's take on M21. Fine, M21 will be not equal to C21. That is because 2 plus 1 over here is 3 and it's an odd number. So signs get changed. So here you're going to have 3. Then C22 will be equal to M22, that is equal to 0. Then we have M23. 2 plus 3 is 5, which is odd. So signs get changed. So minus 1. Then we have M31, which will be equal to C31, that is equal to minus 3. Why? Because 3 plus 1 is 4 and it's an even number. So that will be the same number. Then 3 plus 2 over here is 5, which is odd again. So the signs get changed. Here you're going to have 6 and not minus 6. Now M33 will be equal to C33, that is minus 3. Why? Because 3 plus 3 is 6 and it's an even number. So signs do not get changed. It will be the same number. Now let's build a 3 by 3 matrix of cofactors. What is that going to be equal to? Minus 6, 0, 4, 3, 0, 1, minus 3, 6, minus 3. Now in order to find the adjoint of the matrix, say you're going to take the transpose of the cofactor matrix. That is going to be minus 6, 0, 4, 3, 0, minus 1, minus 3, 6, minus 3. So this is the adjoint of the matrix that we have previously considered. So in this manner you find out an adjoint of a matrix with the order 3 by 3. Well, moving to the last topic, that is division of matrices. Now, there is nothing to discuss in division of matrices. Now, why do I tell that? Because division of matrices do not exist. Alright, in our previous videos, we have discussed subtraction of matrices, addition of matrices, and multiplication of matrices. But here is a big note that I wanted to share with you all, that division of matrices do not exist. And while you're trying to divide the matrices, it is always an undefined answer. And that is the simple thing that I want to share with you all. Well, that's the end of today's video. Make sure you hit the like button, share and subscribe. Thank you.